Okay, great. Um, Thank you, Akin. That was hugely generous as an introduction. And makes me wary of publishing anything now that I know you have an alert when anything goes out. Then thank you for the invite. It's a real pleasure to be here. So today I'm going to talk about something that has emerged as an issue of some import, I think, in the last couple of years, and I've been working on in various different domains. And that is, given that we can now use things like large language models to do things that we previously relied on research assistants or crowd workers to achieve. What does replication look like in this kind of context? And how reproducible are pipelines that rely on things like a large language model? Now, uh, with colleagues at Princeton and NYU, and this work is now forthcoming in the American Journal of Political Science. I'm pleased to say it's not yet out, but you can read the preprint and the references to all of this work in the last slide, which I'm sure I will share with you. Um, we made the basic observation that political science and social science in general, hasn't really paid much attention to questions of replication when we're using language models. And that in spite of the fact that replication and questions of reproducibility have been really at the heart of the discipline since various crises first hit subdisciplines or disciplines such as psychology in the last couple of decades. That is to say, like replication really is at the core of everything we're talking about, particularly in political science. And yet there was very little discussion about what this means in the context of new AI tools and language model use within the discipline. Um, and that is also in spite of the fact that LLMs are being used as if they were just a kind of like a surrogate, a replacement for a human being. They could code things in the same way. We could just rely on them in the same way. And we don't necessarily need to worry about questions of reproducibility or fragility in these kinds of pipelines. We thought that was a problem. And so we looked into what that problem might look like and sort of empirically arbitrate what the contours of this challenge actually are. And that's what I'm going to speak to you about in part of this presentation today. But this talk in general, therefore, is asking what does it mean for a study that uses a language model? And I'm sure a lot of you have been introduced to and are using language models in various different contexts. What does it mean for a language model-based study to actually replicate? And how can we test that rather than just sort of hope for the best? So this talk is based on two contributions of mine. This first paper was published with Eli Paleologu and Peter Turnberg. This is forthcoming now in Political Science Research and Methods, and it introduces a new Python package, though it's adaptable to R using Reticulate, and I might write an R version of this as well. Given LLMs, that kind of task is not as big as it used to be. Um, so I'm going to talk you through what that's doing, and then I'm going to talk you through this second paper, which I wrote with Arthur Sperling and Lexi Palmer. And this is the one that's forthcoming now in the American Journal of Political Science. And this is a kind of like empirical um, investigation into how and why language model-based pipelines might fail in various respects and lead to conclusions and inferences that we might doubt. In other words, both of these papers are really focused on this question of what it means for something to actually replicate when using a language model, and often using a language model in place of or instead of a human being, like we would have used in the past. Okay, so um, this first paper is really a diagnostic tool, and it's intended as a diagnostic tool to tell you whether something is likely to replicate before you even head out and start using a language model, right? To do part of the coding or do some of the annotation of text data in this case, but it could be any kind of data um, within whatever study or piece of research that you're pursuing. And the second paper, as I say, is a kind of audit of both of these things. Um, what they have in common is that, as I say, you know, we are now using language models as a kind of alternative to a human rater or coder or annotator, whatever we might call that person, i.e., somebody who's assigning a code to a piece of data or assigning an annotation, might be a one or a zero, it might be positive or negative to a piece of data. And I'm going to go through both of these, and then I'm going to briefly introduce the tool and briefly introduce a couple of exercises that I've provided you with to go through on your own. Okay, so um, what does it mean when we talk about replication? Um, well, I think there are kind of three versions of this that are common to political science, but also common to social science in general. And I'm sure you'll have seen or heard about versions of these already in your, basic social science training. There's a version of this that is deterministic. This is actually something that Gary King spoke about in the 1990s when people were starting to use programmatic code more and more in order to do statistical analyses, process data in various ways. And what Gary King said is, look, there's a real opportunity here that we can provide code and the original data that we used in order to make inferences, and that code and data can be deterministic. I can press go on a piece of code and I can get exactly the same result as you got by following exactly the same procedure that you followed, and I can check that the results that you claim to have found, you do in fact find, right? They do in fact emerge when I run the data, run the code myself. So this is an exact science in that it reproduces exactly the same results, but it's somewhat fragile and it depends on different system versions, different dependencies, and these accumulate and have accumulated in recent years as we've relied upon things like Python and R, which themselves have dependencies in certain sort of open source packages that may or may not be maintained properly, and so on and so forth. So, in essence or in theory, particularly if we kind of Dockerize or containerize the code and data in some way, we can just run it and get exactly the same result. But it is somewhat fragile because it depends on system settings and so on. There's another version of replication that is more stochastic in nature. It could be stochastic in the sense that you use some kind of like Monte Carlo method, but it could also be stochastic in the sense that we rely upon human beings to do the coding, right? We can ask a set of crowd workers 1 month to annotate some data, and then get another set of crowd workers a year later to annotate the same set of data, and we might get a pretty different or slightly different results. But the basic idea is that, like within a sort of imagined distribution of responses, the downstream inferences that we make from whatever these annotations are going to be robust to whatever human beings that we rely on. Right? But it's not going to be exactly the same result as you got before. And there's a third, which is rule-based, right? It's one example we give in the paper is Key's understanding of what constitutes the American South. And there's just a set of states of the United States of America that constitute the South. So if they are one of those states, then they are coded as a one. If they're not, they're coded as a zero. So this is exact, but it's not exactly scalable, right? It's just a compact sort of set of rules that we apply to some data. Now, our argument in this paper is that LLM-based annotation actually exhibits the weaknesses of all three traditions without really exhibiting some of the core strengths. What do I mean by this? Well, we run or we often run, um, or output annotations on pieces of data by using some programmatic code, Python, R, JavaScript, whatever it might be, right? But what we get back from the language model is not going to be the same every single time, right? So same data, same code, different results, right? Which is a kind of oddity baked into language model-based pipelines that we think is important. Um, so in that sense, they are kind of stochastic, right? But they're actually, what we argue in this paper is they're not stochastic in the same way that sort of using a different set of crowd workers are stochastic. And they're not like that for two reasons. Firstly, the observed variance we see when using different language models and the distributions of error that we see when using different language models are not comparable to what it looks like when you use different human beings. The distributions are bimodal rather than sort of normally distributed. Uh, but also, language models can be deprecated. They can just cease to exist, right? In a way that we hope human beings do not simply cease to exist overnight. So in that sense, they're not comparable to human beings, right? So they are both stochastic in some sense, but not stochastic in the same way that human beings might be. And we also can't call them rule-based, right? Even if we give a language model a set of rules, they may nonetheless fail given the kind of stochastic nature of their outputs. Though that said, LLMs are getting a lot better at sort of rule-based deterministic outputs. A lot better than at least since when we first started working on this paper. Okay. What does paper one do? Well, paper one is this diagnostic tool. So given the problem that I've just set out, okay, that language models um, seem to present a challenge to replication. What first steps can we take in order to mitigate or assuage some of these concerns? Well, in a separate paper, what we thought is that before even embarking on some sort of language model-based pipeline, it's really important to check just how robust your prompt is to repeated turns, to repeated tries across models and within models, right? But also across different versions of that prompt, right? Because if it's the case that I try to uh, annotate something as left wing or right wing, and I get a set of results on one day. But if I slightly adapted the phrasing of that prompt and I got a completely different set of results, right? This presents us with a problem. It presents us with a problem because it means that the pipeline that you're embarking on, that you're pursuing, is very likely not reproducible. Because if somebody else used a different prompt or used a different set of parameter settings, you probably wouldn't get the same result. So what this diagnostic tool is doing is saying, look, let's check just how robust your prompt is to different versions of that pipeline being used. What does it do? Well, it adapts a very well-known iterator reliability coefficient, Krippendorff's alpha, and it just sort of transports it in various ways to the world of language models. Krippendorff's alpha, if you don't know, is basically a way of calculating an agreement score, where one represents perfect agreement and zero is just sort of complete chance, right? And what we do is to do that is we simply subtract the observed disagreement denominated by the expected disagreement from one, right? It's a very simple coefficient that we often use to with human raters to see how in agreement they in fact are when being asked to annotate some data. So what we call in this paper the prompt stability score has two versions. The first is called intra-prompt stability scoring, or intra-PSS. And what we do here is we take the same prompt, how left-wing or right-wing is this tweet, and we run it 30 times. You might run it 50 times, you might run it 100 times. You can do what you want. And we compute alpha across these repeated runs. There's another version, though, which we call inter-PSS. And what we do here is we use a paraphrasing engine called Pegasus, right? And then for any language model that we elect to use, GPT 4.55, whatever it might be, we give that language model many different variants. So in this paper, we use 10 different paraphrase variants within each temperature of the paraphrasing engine, not the language model we're using, but the paraphrasing engine. The idea here is that as we increase the temperature of the paraphrasing engine, the original prompt is going to become more semantically distant from the original one. So we would expect that as it becomes more semantically distant, the stability of that prompt, of the outputs, are going to decrease. So again, we measure that with a version of Krippendorff's alpha across the different prompt variants. So the idea here is to check, you know, if I make just a slight adaptation, maybe temperature 1 to my original prompt, do I see substantively different results, different annotations output by the language model we're using? So it's a way of diagnosing before we even pursue some piece of research whether or not the prompt we're using is actually robust to different variants of that prompt. We use a bootstrapping technique to recover confidence intervals, and this is what some of the results look like. We do this across, I think, 6 different data sets and 12 different outcomes. I think that's right. But I'm just going to show you one of them here. So this is from some UK survey data. It asks respondents what the most important issue is, and you're getting the language model to essentially recover from a set of options. From the open text response of the survey respondent what the most important issue is. So here we're just using one prompt, and that prompt will be something like, tell me what the most important issue is from this survey response from this set of options. And the options might be, climate or the economy or whatever it might be, right? So we see here that this is relatively stable, right? We have a Krippendorff's or intra-PSS score, which is essentially a kind of repeated Krippendorff's alpha of about 0.92 over the 30 different runs of this prompt. Then when we look at the inter-PSS, that is using different variants of the original prompt, we see that as we go from 0 to 1 in the paraphrasing engine, we don't see a huge difference, right? This is probably around, what was this, 0.85 or something like this, which is, reasonable or very reasonable agreement coefficient. But then when we raise the temperature to around 1.5, the inter-PSS suddenly plummets, right? So this is worrying. And this is, therefore, we argue, a really useful diagnostic for us, because we can say, well, if somebody used even just a slightly adapted paraphrased prompt from the one we originally used, the agreement between runs is going to it seemingly decreases dramatically. And this has bearings, right, for downstream consequences for how we imagine being able to reproduce a piece of research that uses this kind of approach. Now, what we did in the second contribution that I've spoken to you about is we looked at actually like how big an issue the non-reproducibility of language model-based pipelines might be by um, essentially replicating a set of replications, if you like. What do I mean by that? Well, there's an argument that we often heard that even if there's some kind of stochastic element to language model outputs, this is just the same as human crowd workers, right? Like, if I asked a different set of crowd workers from 1 month to the next to annotate a set of data, I'm going to get different results. And we agree. But we wanted to empirically arbitrate what the stochastic nature of the human outputs look like compared to that of the language models. And further than that, we wanted to look at what the consequences of that might be for any inferences, statistical inferences we're making that are based on the annotations that the language model is outputting. And this is what that looked like. So what I'm showing you here is a comparison between repeated runs of the crowd when asked to annotate some data for ideology and to annotate some data for whether it is speaking about economic or social issues. And on the x-axis here is the F1 score. So the accuracy score compared to the gold labels that we have from the original data. And we can see that the F1 score of the crowd is actually tends to be lower than the most powerful models that we tested, which were the OpenAI ones at the time. I think this was GPT-4o when we were doing this work, which is obviously already dramatically outdated, which is one of the problems with doing this kind of research. But anyway, the point is that if we then look at the run-to-run variability, the crowd is kind of somewhere in the middle, right? So, and the least variant language models are the llama models here, which show almost deterministic outputs, almost exactly the same every single time. OpenAI is second, and then the crowd is third. But if we look at Gemini, Gemini is like way, way, way more variable in its outputs than the crowd. So that's one reason to think, okay, well, if somebody were to use a different model, or if they were to use Gemini alone, well, in this case, or at least for these Gemini models, we wouldn't be able to recover the same kinds of annotations with the same kind of variability that we would observe when using the crowd. And as a side note, we show separately in this paper that actually when you look at the distribution of the errors when looking at the crowd versus when looking at language models, the distribution of the errors looks very different when you're using a language model versus any language model versus when you're using the crowd. But I encourage you to take a look at the paper itself because I won't have time to speak to all of that today. Now, one other remark that we often heard was, well, why don't you just set the temperature of the language model to zero? For those that don't know, that setting temperature to zero is a way of kind of effectively constraining the stochasticity of the model output. So, what we heard over and over again is if you care about the deterministic outputs, then just set temperature to zero. Now, what we also show in this paper is that for closed source models like GPT-4o in this case, but any closed source model that is produced by Google or OpenAI or Anthropic, setting the temperature to zero does not fix the problem. In fact, the distribution of the correlation coefficient between runs of the same model and the same data range from about 0.8 to 1. In other words, this does not produce deterministic outputs run on run, which means that the downstream inferences from these annotations could be quite different depending on what day of the week you chose to do the annotations or time of day. We also find that this has consequences for downstream inferences. What do I mean by that? Well, we tested this by taking some data from a contribution by Hopkins and colleagues. This was data that was released by Upworthy, actually. And what they were testing here is whether headlines that cue some kind of identity, be it a racial or gender identity, whether they are clicked on more often than headlines that do not do that. So they needed to annotate for whether the headline contained a gender cue or a race cue. And here's what we found. When using different models across different versions of the outcome, the gender coefficients were pretty uniformly all significant, and the race coefficients were pretty uniformly non-significant, which was the exact reverse of what they found in the original paper. In other words, the consequences of the annotations being output by a language model are material, right? We would have made a very different conclusion if using a language model in place of a human being in this example. And there are other examples in the paper too. So, kind of bringing this all together, I just wanted to sort of give you a very, very in brief rundown of what I think it's important to think about when using language models in any kind of research pipeline. I would encourage you, of course, I would, to use our prompt stability Python package as a kind of initial diagnostic check of just how stable, invariant your prompts are across runs and across different versions of the run. It's really important to do things like validating a subsample of the data against gold standard codes. I know that there are question marks over what's going to constitute a gold standard given the apparently ever expanding abilities of language models. But being able to provide some kind of accuracy statistic when doing annotations of this sort is hugely important. And one way of doing that is simply to take a subsample of the data, and you could manually code it yourselves in order to see how accurate a language model is or is not. It's important as well to think about, and we discussed this a bit in the prompt stability paper, to think about just how stable your inferences are across different models and across different versions of that same model. And if we find very different downstream inferences, then again, this is reason to be somewhat wary of what we're doing. We also encourage in the paper with Arthur and Lexi to prefer, at least as a first point of call, open weight and versioned models. The reason is that OpenAI and Anthropic and Google can just shutter models overnight. They can just cease to exist, which represents a real challenge, right? If we care about reproducibility, if we care about replication, because somebody could return to my replication materials in 3 years' time, try to run them and find that GPT-4o no longer exists. And that's, in fact, a very likely thing to happen. OpenAI have already deprecated and shuttered a number of models, including GPT-4, I believe, just because it was so sort of inefficient, I think, on their side. And the final thing is to document everything. By everything, I mean things like the model, the version of that model that you used, the prompt that you used, the settings, the parameter settings, things like temperature, top P, these decoding parameters, the date on which it was run. And on that note, I wanted to also mention this multi-author contribution that came out a few weeks ago in Nature Human Behavior, on which I'm also one of the authors. And this provides you with a standardized and crowdsourced, Delphi-sourced reporting checklist for using language models in behavioral science. I was told, as an aside, by one of my colleagues recently that they'd used Claude Code to fill in the checklist, which makes me think that we need a checklist to check the checklist, but we'll see what happens there. Okay, so we've walked through sort of 4 types of potential fragility that characterize the use of language models in the social sciences. The modules or exercises that I've provided you with to go through on your own today, firstly, try to recreate findings or some version of the findings from the prompt stability paper. And the second one tries to recreate one of the findings from the language model replication paper, this sort of empirical paper on what replication looks like when using language models in place of human annotators. You don't need an API key for either of them. I've set it up with Ollama, which I'm sure people in the room will be able to instruct you on, but there is a version of both scripts that permit both, or this just the second. I can't actually remember now. I should remember that. I think just the second that permits the use of an API key for for OpenAI, whatever it might be. what does this look like? Well, the first one uses the prompt stability package, and it uses OLLAMA within this. I recommend using some small model like the 3 billion parameter Llama 3.2 model or some similar one to that. It specifies a constrained prompt format. So here, and you may have heard about this in other sessions, it specifies the exact type of output we want. So here, an integer in the form of 1 or 0 for whether or not a piece of text, in this case, and these are speeches by US presidents, for whether or not it contains populist language. This is the main prompt stability function. Sorry, here for intra PSS and here for inter PSS. And here I'm providing you with a set of prompt variants, I believe, in the code instead of generating them using the paraphrasing engine, though you can go away and play with that yourselves as well. The task is essentially to test different versions of a prompt aimed at annotating a piece of data. So you'll see something like this as we increase the temperature, the paraphraser temperature, the rewording distance. In other words, we might see some change in the interprompt stability score, or the Krippendorff's alpha. Uh, in the second module, here I'm providing you with a stricter prompt and a looser prompt, defining what it means for a piece of speech to contain populist language. And I'm also including the original gold label or original prompt as well in this exercise. And the task is to not predict, I should say, observe which prompt inflates the rates of populist speech across parties. That is to say, if we use a looser definition of what populism means, do we observe in our prompt at least, do we observe sort of materially different downstream consequences? And this is what I got at least from my run. I don't know if you'll get exactly the same, just because that's how language models work. But when we use this kind of looser definition of populism, we see a much higher rate in this run at least of populist speech among Republican presidents. So I've provided your TAs and Akin with these exercises that are split into a first module, module 1, which is the prompt stability one, and module 2, which is the annotation inference. I've also provided some reference solutions. I'm not sure if you're going to be given access to those straight away, but I'll leave it up to you, Akin and colleagues, whether you wish to hand those over. And there's a README within each module as well that gives you both instructions about how to run the code, but also has a set of questions about different parts of that code and to-do items, and some reflection questions for each group. And these are the references to the two papers that I spoke to today. And I think I'll stop there. I'm happy to take any questions. I'm also happy if you want to just run off and start playing with these exercises.
Well, thank you so much.
Thank
I
you.
will ask the first question abusing my role as the organizer. So for like benchmarking different LLMs on producing both reasoning and a verdict on information scarce incidents, like for example, a very recent diplomatic incident that doesn't really have that much news to extract from, like Trump overturning Belgium's red card decision in the World Cup, for example. In that kind of scenario where we have multiple LLMs, to what extent would you expect temperature to play a role in differentiating between LLM reasonings from like low information events?
hmm So, what would we be trying to annotate for in this context?
Annotate for basically of accuracy and like some uh
Mm.
like a response that I would like very loosely defined.
Yeah, that's a great question. So the information retrieval tasks that we test in these papers have to do with whether or not it can retrieve the salient piece of information from some description of an event. So that might be a protest, it might be, a manifesto or whatever it might be. Like, does this mention the economy? Yes, no. Um, so in that sense, we're testing something slightly different. I would suggest, though I don't know, that in the case of some kind of low information or recent event, then you're gonna lean on some kind of agentic tool calling thing with web search, and in that sense, temperature becomes less of a consideration, in part because I think you can't even, I mean, the baking temperature into these kinds of tool cooling flows doesn't really make sense. Um, which is kind of a long way of saying I don't know, but basically, I would probably just lean on some kind of tool calling pipeline rather than relying on a kind of language model alone, if that makes sense.
Yeah. Do we have any questions from the audience? Raise your hands, introduce yourself, and like shout so that he can hear you all the way here. Yeah, come here. Yeah, definitely. Because like it's a long distance.
Okay, hello. Thanks.
Hi,
This is Ali. I
hi,
have
Ali.
some questions first. I was thinking that maybe the root cause of this prompt fragility problem is that we might need more context. I
Mm,
mean, when you give a task to people, they know something and they are able to search. But when you do it with LLM, you should give the context.
mhm,
Have you tested these and maybe it
mhm.
would enhance the results?
Yeah, that's a great question. There are two parts to my answer. Well, three. The first is no, we didn't test this, really. The second is that yes, it is likely that some kind of context is going to improve performance. Though I did just review a paper, positively review a paper that found that using what is often referred to as in-context learning does not reliably improve annotation quality across various different tasks in a consistent way. Um, and then the third thing I have to say is that, and this is a kind of high level response, but also an encouragement to read a different paper by one of my former colleagues, is that there are so many different ways of specifying parameters for language model based pipelines. Right? It could be the prompt, it could be the model, it could be the version of the model, it could be the date on which you ran that model. It could be the top P or temperature settings. It could be whether you use context or you don't use context. It could be tens of different other settings, right? Um, and this means that the source of um, any observed error is often very unclear. Whether the error is as a result of the prompt, whether the error is the result of the parameter settings, we often don't know. My former colleague at NYU, Solomon Messing, has a really nice paper on archive, which I will share with Akin because the paper title I can't entirely remember. It's something like total language model error or something like this. And it's basically a way of um, empirically or no, of estimating the source of any downstream error in an annotation, a language model-based annotation pipeline by using some kind of mixed hierarchical modeling technique. I will share that with you because I think that speaks to this problem quite nicely. And yes, I would also encourage looking up an approach by Musashi Hink and colleagues, Brandon Stewart and others from this paper, but it's called design-based supervised learning, which is a way of correcting for any potential language model error using gold standard human annotations.
Okay, thanks. I have another question.
Mhm.
I saw the materials and the prompts, and I think you have taken an inductive coding approach. But what if we take a deductive one? I mean, giving the model some options. That might enhance also and fix the fragility and instability problem.
Mhm.
This is
Yes, I think so Arthur Sperling has a paper with James Bisbee, I believe, that's looking at more deductive annotation questions. That is to say, um, questions, yeah, as you put it, sort of based on a set of options and a set of definitions attached to those options. And it does seem that these tasks that are often referred to more as sort of information retrieval tasks rather than more inductive coding tasks, language models are getting better at them. That said, they are still fragile um, in the sense that they are highly dependent on the prompt definition. Yeah.
okay. And finally, I mean, when we do these tasks, we humans or experts, I think there is also some sort of fragility. You know, you think something is right, and then tomorrow when you come back, you think, oh, maybe it's not right. So how much difference is valid?
Yeah. Yeah, that's a great question. So it speaks to a finding in the paper with Arthur and Lexi that I didn't present today, but I encourage you to consult the paper because what we do there is essentially try to attempt to answer that question. Because you're completely right. If if you were to consult me tomorrow on a survey question you asked me today, I might give you a different answer. The issue with that comparison with human beings, or I don't know whether you're suggesting this or not, but some have suggested that language models are wrong in the same way that human beings can be wrong. Is actually when you look at the distribution of error among human beings, it looks very different to the distribution of error among language models. That is to say, if I ask a set of human beings from one day to the next exactly the same question, the distribution of that error will be relatively normal. If I ask a language model that question repeated times, on repeated times, it will often give exactly the same result. And then for some reason, on one separate occasion, it will spike and go here. So you have this like weird bimodal distribution of the error, which doesn't look human at all. It looks like this sort of otherwise inexplicable, very spiky distribution. And then if you actually sort of, project the error into some two-dimensional space, which I've done in a separate project that is unfinished, so I can't really show the error also, the distribution of the error also looks very different across models when compared to humans. So it's also important, in other words, not to pay attention not just to overall accuracy statistics, but to the kind of the shape or geometry of error we're observing when using language models, which often doesn't look very human at all.
Okay, thanks. Thanks.
Thank you. Great questions. Thanks a lot.
Take your phone. Take your phone.
Sorry.
Any other questions? Chris, we're grateful. Thank you so much.
Thank you so much. I can
hope to actually find some departmental money to bring you actually here in person next year.
that'd be lovely.
That would be amazing. Let's give a round of applause, people. Chris.
Thanks so much, everyone, and enjoy. And
Thanks so much.
Thank you, Akin, for running this.
Of course.
It's a great thing. This is the reason, by the way, what you're doing. I kind of got into this whole field. So it's so lovely to see it's still going, people still attending, and people still running it. So enjoy and make the
Yeah, it's
most of
a
it.
wonderful group this year. So wish you were here, but
Fantastic.
hopefully next year. Yep.
Thank you,
Take care.
Akin.
Bye.
Great to meet you. Bye bye.